So we'll start by putting these points on a 3D coordinate system. So the 3D shape is kind of like a pyramid with a triangular base. The XZ plane is the left side as we're looking at it. The ZY plane is the back side. The XY plane is the bottom. And then the plane that I've got outlined with the three lines from the point 200 to 050 to 004 is the other side or top side of the pyramid. So what we need to do is to find the equation for that plane that's on the top of the figure. So what we're going to do is we'll take, starting here with the point 200, we'll find this vector over to the other point on the y-axis, and we'll find this vector to the point on the z-axis. We'll just call those u and v because that's traditional with vectors. And so the vector u is going to be from the point 200 to the point 050. So that would be a -250. The vector v is from 200 to 004, which is going to be a -2, 0, and 4. So now we'll find the normal vector by doing the cross product of those two. So I will do this on my calculator. That comes out to be a 28 and 10. We can divide those to simplify it. So if we divide through by 2, we'll get a 10, 4, and 5. So there's a normal vector. We'll use any of the points. The one that I've got with the blue dot is perfectly fine, 2, 0, 0. So the equation of that plane then would be a 10, and then x minus 2, a 4, and y minus 0, and 5, and z minus 0 equals 0. So again, these 200 is here, and 1045 is here. So we'll simplify that. That comes out to be a 10x minus 20 plus 4y plus 5z equals 0. Now I'm going to solve that for z by moving everything else to the other side and dividing by the 5. And that comes out to be 20 minus 10x minus 4y all over 5. You could write that different if you like. However, this thing is z simple, and when we make a line from the bottom up through this plane, it will go from z equals 0 to that plane, z equals 20 minus 10x minus 4y over 5. So that will be our first order of integration. Our integrand is going to be a z. We're going to start with a dz, and it's going to go from 0 to 20 minus 10x minus 4y. So then what we need to do is take a look at the projection of this entire figure down onto the xy plane. So we're going to draw us a new coordinate system with just a y and an x. And as you can see, when we squash this down onto the XY plane, we're going to have an x-intercept of 2 and a y-intercept of 5. So from back in algebra, that line that goes between those two, which would be this one this one right here, is going to be y equals, that's down 5 and to the right 2, plus 5. Y equals mx plus b. So if we choose to partition this with vertical rectangles, that means we'll integrate next with respect to y. We need y's to go from the x-axis, which is y equals 0, to the line, which is y equals negative 5 half x plus 5. And then finally, we have the x's. As you can see here, the x's are going from 0 to 2. And once you get there, you can finish that with, hand, or you can do it on the TI calculator. On the TI calculator, we come out with exactly a 20/3. However, I do recall that the instructions in the problem wanted this to 2 decimal places,